All right, welcome everyone. We are here today for some STEAM time, Geology in Motion. We're very excited you're able to join us today. This is going to be a very fun activity. And I'm joined today by Miss Erica, who's going to tell us all about this fun activity. Miss Erica?
Hey everyone, my name is Miss Erica. I work at Riverview Library, and today I am here to present Geology in Motion. So we're going to start by talking about something called plate tectonics, which is very important to this topic. All right,
Turning
so
our camera off here for a sec so you can see the full screen.
yes, so now we can see all of the beautiful diagrams we have here. We're going to talk about tectonic plates. So when we're looking at the Earth and the structure, we have a diagram on the left over here that shows the outer crust of the Earth, the mantle, which would be in between the crust, and the innermost part, which is the core, which is that red part in the center. And the theory of tectonic plates is that the Earth is broken up into these different land masses, which you'll see on the map of the Earth on the right. So you'll see that there are a bunch of different plates, like the Pacific plate, the North American plate, the African plate. These are all of the tectonic plates that are constantly moving on top of the Earth. Now the outer layer is the crust, and then underneath that we have the mantle. If you look at the diagram on the left, you'll see that there are some swirling arrows showing that there's constant motion going on in the mantle. So on the top we have our crust, which is all of these plates, and underneath that we have the mantle, which has swirling molten lava rocks. And that motion is going to create motion up top on the crust, and it's going to make these plates move around. So we are going to do a fun experiment that simulates this motion, and it's called the graham cracker tectonics experiment. And what's great about this experiment is that we get to use delicious ingredients to do science. So some of these supplies include frosting or icing, depending on what you call it, red food coloring, especially if your frosting is not red, and that is going to symbolize our molten lava rock mantle that's constantly flowing. For our tectonic plates, we're going to use graham crackers, or you can use whatever kind of cracker you have on hand. For our special tectonic plates that have ocean on top of them, like the Pacific plate, this is an oceanic plate, and we are going to use a fruit roll-up to distinguish that from the graham cracker plate. In addition to that, we're going to use a plastic knife to spread out our frosting, and we're going to spread it out on either wax paper, if you have it, or a paper plate. Lastly, we'll need a cup of water for one of our experiments, and we will get started and show you 4 different types of tectonic movements with the frosting, crackers, and fruit roll-ups. All right, so for our first experiment, we are going to show what happens when 2 of our graham crackers move away from each other. Now remember, the graham crackers symbolize our continental tectonic plates. So these are tectonic plates that have land on top of them. When we get 2 of these tectonic plates that are next to each other move away from each other, we are going to see what comes as a result of that. So when you're setting up your experiment, make sure you have your paper plate, your frosting with your red food coloring if you have it, 2 graham crackers, and then we'll see what happens. We're going to demonstrate what happens when these graham crackers move away from each other. So we're just going to go to a quick video here. It's going to show you the first tectonic plate experiment. Okay, so in that experiment, we put 2 graham crackers on top of frosting, and we have those graham crackers move away from each other. This is called a divergent plate boundary, and that just means that these 2 tectonic plates are moving away from each other. When they moved away from each other, you could see that there was red frosting in between the 2 plate boundaries. And when this happens, this red frosting symbolizes the molten rock that's underneath the Earth's crust. So if you have this molten rock that's coming up in between the 2 continental plates, what kind of event do you think would happen as a result? If you have an idea, go ahead and type that in. What do you think would happen as a result of the tectonic plates moving away from each other?
Miss Erica, are you ready for the big reveal?
I am ready.
Great. Let me pull that up. Ta-da!
Okay, so look at this. We have a volcanic eruption that can happen. So isn't that crazy? These 2 tectonic plates just happen to flow away from each other. And because that molten rock is underneath the crust and it has somewhere to go, this can result in a volcanic eruption. So if
And
you
our
guessed
audience was
volcano,
right. Yeah,
how
our
many
audience
people
was
got
right. And
volcano?
we had several guesses about lava erupting from a volcano. Good
Absolutely,
job,
you
guys.
guys are smart.
All right, I'm going to move right over to our second big experiment.
Great. So for experiment number 2, this is called the transform plate boundary. And what's happening here is we have 2 graham crackers symbolizing our continental tectonic plates. These graham crackers or plates are going to glide past each other in opposite directions. If you look at the diagram, you'll see one of the graham crackers is moving forward and the other one is moving backwards. And they are sliding past each other. So we'll see what that looks like in the video. All right, so in experiment number 2, we have 2 graham crackers. Those are going to be our We'll put those on the frosting and we'll have them slide past each other. So we're placing them on the frosting. One is going to move forward, one is going to move backwards in just a moment. And I'm showing that they're moving in opposite directions, but sliding past each other. And when they slide past each other, they're not going to glide smoothly. There's going to be a lot of friction in between the 2 plates. That causes a lot of movement. So when these tectonic plates slide past each other, what kind of event do you think might occur? Go ahead and type in your guess in the question box.
So I'm going to pull up our screen here again where you can see how we set up that experiment. But yeah, what do you think happens when these 2 plates grind against each other? So, I mean, we call it a fault zone here on this slide, Miss Erica. When I think of a fault, I think of a big one that we know of in California.
Are you talking about the San Andreas fault? Is that the one?
Looks like.
You are on the right track. Absolutely, this can cause an earthquake. So you have those 2 plate boundaries grinding past each other. All this friction and motion can cause an earthquake. And that's just from plate tectonics. So if you
You
guess
might feel that when you feel the crackers grinding against each other, that they kind of make that kind of grindy, grumbly, crumbly noise.
Absolutely.
All right, move right into our third experiment.
Awesome. So experiment number 3, we're using graham crackers again. We're also going to use a cup of water, or if you want it extra yummy, you could use a cup of milk. Up to you. But we're going to use graham crackers and some water. And what we're going to do is before we place the graham crackers on the frosting, we're going to dip one edge of each cracker into the water just for a second before we place it on the frosting. And then we're going to push the tectonic plates together so they're moving towards each other. This is our convergent plate boundary, and we'll show you what that looks like in our video. All right. And as you can see, we have our plate with our frosting. We also have a cup of water. You can see the measuring cup on our 2 graham crackers, which are going to be our continental plates. So we will go ahead and take those graham crackers and dip each of them into the cup of water just for a second, or a cup of milk. You dip the first one and place it on the frosting. Then we'll go ahead and take the second cracker and dip it into the water as well. And we're just going to dip one edge into the water really quickly. And then we'll put those 2 wet edges next to each other. And we're just moving the plate to see a little bit clearer. So with those 2 wet edges, they're going to crash into each other or collide into each other. And we'll see what happens as they collide. And it looks like there's something forming in the middle. What do you think is forming in the middle of these 2 tectonic plates? Go ahead and type in your answer into the question box. What do you think is happening here? What is being formed as a result of these 2 graham crackers crashing together?
You know, it looked almost like there was a ridge building up.
Absolutely. What kind of a ridge?
Like almost like there was some uplift happening there.
Yeah, there was definitely some elevation going on.
Yeah.
Definitely a peak in between those 2 crackers there. So if you happen to guess mountain, you would be correct. So when we have 2 of these continental plates colliding or crashing into each other, this is called a continent-continent collision. Excuse me. It's also called a convergent plate boundary. That just means that the plates are coming together. When they come together and they crash into each other, that land builds up in elevation and it can form a mountain. So if you guessed mountain, you would be correct.
Good job. All right, we are on to our 4th and final experiment of the evening.
Awesome. So our last experiment, we are going to use the fruit roll-up that was in our supplies list. And when we were talking about tectonic plates at the beginning, you'll notice that some of the tectonic plates were covered by land, and some of the tectonic plates were covered by ocean, like the Pacific plate. So in this experiment, our oceanic plate is going to be represented by the fruit roll-up, and the continental plate is going to be represented by the graham cracker. We are going to have these 2 pieces collide or crash into each other, just like we did with the previous experiment, but we'll get some slightly different results because these 2 tectonic plates have different densities. So looking at the video, I have my graham tectonic plate, which is going to be my continental plate, and my fruit roll-up. So again, the continental plate is a graham cracker. That's going to be a lot less dense than my fruit roll-up. So my fruit roll-up is my oceanic plate. It's going to be a lot more compact and dense and heavy. So when I put that on the frosting, I'm going to push down. And when I place my graham cracker tectonic plate, I'm just going to lightly place it on the frosting. This is showing that the oceanic plate is denser than the continental one. As we push them together, you'll notice that the fruit roll-up slides underneath the graham cracker tectonic plate, and the graham cracker ends up at an angle pointing up. So as these 2 plates crash into each other, we have the oceanic sliding underneath the continental plate, and we have this energy that's released as a result of these two things crashing together. So this is another event that can occur, and it's as a result of something called subduction. So we have a continental plate and an oceanic plate crashing into each other. One of them slides underneath, and this creates almost a snapping motion that's going to snap upwards and create an event. What kind of event do you think this might create? Not a volcano, not an earthquake. What do
I
you
don't
think?
know. When I think of big things moving in the water, like if I'm splashing around the pool or in the tub, if I
Mhm.
make a lot of big movements there, that can make the water do a lot of moving too.
Yeah, just imagine if you had some kind of snapping or slingshot motion on the bottom of that tub,
Hmm.
it's going to create some waves that are coming up. And these are a special kind of wave. It's not just a regular wave, but it's actually something called a tsunami wave. So this is a wave that is, or a series of waves that's caused by some kind of disturbance on the ocean floor. And it can be caused by these plates crashing into each other in this way, where it's a continent and oceanic plate. This causes that snapping motion, it sends that energy up, and it can create a huge tsunami wave. So did anyone guess tsunami?
We did. We had a whole bunch of people guessing tsunami. Good
Oh, we
job.
got some really smart cookies here, no pun intended.
All right, let's move over. Before I go on to the next slide, I have to tell you, Miss Erica, I was looking at National Geographic Kids on the library website for a different program right before we started. And do you
Mhm.
know what I learned about plate tectonics in the ocean?
What's that?
I learned that the Indian subcontinent is literally the fastest plate on Earth.
Oh, very
India,
interesting.
the plate that India sits on, it actually is twice as fast as any other plate on Earth. I
And
thought that was pretty cool.
that's really cool. And it just shows you that that mantle is moving around in uneven ways. So these plates are moving away from each other, past each other, towards each other, and it varies depending on what spot of the Earth we're talking about. Um, So we'll
Oh,
go ahead and I guess I will talk about some of the resources that I use just with my library card when I was researching plate tectonics. And one of the books that I found on our website, specifically on Hoopla, which is a great platform for ebooks, movies, TV, music, all kinds of stuff. One of the ebooks I found was called Fault Lines and Tectonic Plates, Discover What Happens When the Earth's Crust Moves. This is by Kathleen M. Reilly and Chad Thompson. This book is fantastic, especially if you're doing some kind of science project on tectonic plates. And if you look at the cover, it shows you the Pacific plate, which is an oceanic plate, and this red outline, which shows you the Ring of Fire, which is one area that has a lot of earthquakes and volcanoes. In addition to that, we have another great resource called Science Online. And on this resource, I was able to find a cool science experiment called Tsunami Architecture, where you can make your own tsunami wave pool. Both of these resources are on our website under the Kids tab. So you can visit these resources and plenty of other ones like Nat Geo for Kids and World Book for Kids. And this is all on our website for free with your library card.
all right. I'm going to go ahead and turn my camera back on as we go over to our next slide so that
And
we can do
I'm
some
going.
question and answers with our audience. We have had so much fun showing you guys this experiment. And if you have any questions about anything that we talked about, go ahead and type it into that question box. If we know the answer, we would love to share it with you guys live. If we don't know the answer, we will do our best to point you to where you can find that out. I already see we have a question in here that we'll read in just a moment. But I know we're actually at the end of our time. So if any of you don't have time to hang out and listen to the live question and answer session, you can always catch up with us later. We will send out a survey to everyone after the program that you can fill out, let us know how we did, things that you would like to see in future programs. And if you have any questions that you can't get to live, you can put them in that survey as well, and we'll get back in touch with you. You can also reach us at hcplc.org/contact, has all of our information on there. And hcplc.org/events has all of our upcoming programs, especially our summer programs. I know we have a ton of live and virtual programs, especially geared towards our summer reading program. So if you go to hcplc.org/summer, that'll have those specific summer reading programs. And as always, hcplc.org/kids has all of these great learning resources for kids. So I'm going to go ahead and click over to our questions here, and we'll do our best to answer them. So our first question is, if two tectonic plates move on opposite sides, will a volcano still form? So I'm not quite sure what you mean by opposite sides, but I think that a volcano can form anytime that you have that disturbance in the crust that allows that to open up, where all that moving and oozing and gooing stuff that's under the surface can then come out, where it has that relief from that pressure. So I'm not 100% sure what you mean by the plates moving on opposite sides, but yeah, anytime something moves where it creates that deep disconnect and that gap is a possibility for a volcano to form, sure.
Yeah, and I just wanted to add that a way to think about it is to think about more than one plate. So instead of just looking at one plate and what might happen on one side or the other side, usually these events happen where two plates are moving away or sliding past each other or into each other. So try to think about like the boundaries between the plates, and I think that might help the person who asked that question.
Those interactions, yeah. And that's maybe something that they can do if they do this experiment at home. They can kind of try that out and see how it works, if their idea works out with the frosting and the crackers.
Absolutely.
All right, what do we have next? We have a question that asks, how high can a tsunami go? Ooh, I don't know the answer to that as to what the maximum height for that is. That I'm not sure of. But
for some reason, I want to say 100 feet, but that's just off the top of my head. If you check out one of our Science Online or World Book, it'll give you a precise number. I know they can be as fast as a Boeing airplane. They're very tall, and they get taller as they approach a coastline. That's what makes them kind of scary and dangerous.
I think it would really depend on how much energy is involved. If there's a huge amount of energy from that initial movement of the Earth, and then that energy builds and builds and builds as the water moves. So there's probably a lot of complicated math involved in finding out what the maximum is, but yeah, really, really big if it has enough room and momentum and energy.
Absolutely.
Let's see, what do we have here? What would happen if two ocean crusts bumped into each other?
So two ocean crusts would have similar densities. So I think the answer varies. It could create a mountain underneath the water. So an underwater mountain ridge, which is kind of cool because we only think of mountains really on land, but they're in the water too. So that's something that could definitely happen with two fruit roll-ups or oceanic crusts crashing into each other.
There are some cool maps that you can find on our kids resources that show you the what it looks like under the ocean, what the topography, what the land masses that are under the water, what those look like. So that would be an interesting way to look at those.
Great question.
All right, and we have a question is, when frosting is in the middle of two crackers? I think the answer to the question when frosting is in the middle of two crackers is, I think the answer to that is delicious.
A delicious volcano.
That sounds like a tectonic sandwich to me.
And you can eat this experiment afterwards. Just don't overdo it.
And if you don't have a sweet tooth, I mentioned it before we got started. If you don't have a sweet tooth, you can do this at home. If you have like a rectangular cracker and maybe some hummus instead of the frosting, and instead of the fruit roll-up, maybe some thin sliced vegetables that you then trim down to a rectangle shape. That could work as well. So yeah, you don't necessarily have to have a sweet tooth for it. If you don't have crackers, you could use a piece of bread. You could have some pita or naan that you then cut down to a rectangle shape. Yeah.
I wonder if you could use pizza crust. That would be appropriate.
Ooh, pizza crust, maybe with tomato sauce instead of the frosting.
Yeah.
Yeah, like the Lunchables pizzas. Yeah, there we go. All right, folks. If you have any follow-up questions, feel free to get in touch with us through any of these methods that we have on the screen here. Or like I said, if you have a follow-up question, put that in the survey as well. We'll do our best to answer those for you. Had so much fun with everyone today. So I hope you enjoyed it as well. And we will see you for the next Steam Time session. Bye, friends.